Welcome, children. Today we start with lesson 8, earthquakes. In this video, I will explain the meaning of earthquake, the different causes of earthquakes, and the anatomy of an earthquake. So, what is the definition of an earthquake? An earthquake is defined as a tremor below the surface of the earth which causes the shaking of the crust. As you can see, the shaking of the crust has caused so much devastation. Now let us understand the various causes of earthquakes. Earthquakes are caused by the strain in the Earth's crust. When the Earth's crust is unable to accommodate itself to the strain, it results in a sudden release of tremendous energy in the form of a sudden violent shock. A series of shocks that result from sudden earth movement are known as earthquake. The waves spread out from the seismic focus and can cause widespread destruction. Seismic focus is the point inside the Earth's crust from where an earthquake originates. The first cause of earthquakes are volcanic eruptions. Volcanic eruptions are one of the main causes of earthquakes. During a volcanic eruption, hot gases are pushed upward and they push the Earth's crust upward violently, causing earthquakes. Volcanic activities and earthquakes are interrelated. An earthquake follows a volcanic eruption, and volcanic eruption follows an earthquake. The violent eruption of Krakatoa volcano between the islands of Sumatra and Java caused a severe earthquake around a vast region. The earthquake generated a tsunami which killed about 30,000 people in Java and Sumatra. So, as you know, a tsunami is a huge wave which, when it crashes along the coastal areas, causes huge loss of life and property. The second cause is plate tectonics. According to the plate tectonics theory, the crust of the earth is made up of a series of movable plates. These plates move and slide over each other. Most earthquakes occur on account of plate movements. When two plates slip past each other or collide against each other, their edges produce faults along the lines of weakness. The tectonic earthquakes are most frequent. These earthquakes are immensely powerful. They occur in high risk regions of the Pacific Ring of Southeast Asia, that is, Philippines and Indonesia, and northern India along plate boundaries. In India, a severe earthquake occurred at Bhuj in Gujarat in 2001 due to the lowering of the Indian plate below the Asiatic plate. There are three types of plate boundaries. First, we have the convergent plate boundaries, where two plates are converging towards each other. Then we have divergent plate boundaries, where two plates are moving away or diverging from each other. And then there is the transform fault boundary, where two plates are sliding past each other. Normally, moderate earthquakes are caused along the divergent plate boundaries because the rate of rupture of the crust and the consequent movement of the plates away from the mid-oceanic ridges is rather slow. Thus, shallow focus, that is about 30 kilometer deep earthquakes, are caused along the mid-oceanic ridges. Earthquakes of a higher magnitude and a deeper focus, that is about 700 kilometers deep, are caused along the convergent plate boundaries. This is due to the collision and subduction of the heavy oceanic plate beneath the lighter continental plate. Then we have the transform fault boundary, where two plates slide past each other. As the plates grind together, they get stuck and the pressure builds up. Finally, the pressure between the plates is so great that they suddenly break loose, leading to an earthquake. The next cause of earthquakes is folding and faulting. Now let us understand the meaning of folding and faulting. When rocks are subjected to horizontal compressional forces, it causes the rock strata to fold. As you can see in this diagram, this is the folded rock strata. When the compressional force is extremely great, the folded rock strata breaks. Moreover, flexible rocks like sedimentary rocks fold under compression, but brittle rocks like igneous rocks break under compression. This causes sudden dislocation of the rock blocks, causing earthquakes. Now let us understand faulting. Here in this diagram, you can see tensional stress acting on a block of rocks. As you can see from these arrows, that this is tensional stress. A rock under stress will eventually fracture. If there is no movement on either side of a fracture, the fracture is called a joint. But if the block of rocks on one side or either side of the fracture move, the fracture is then called a fault. So when blocks of rocks along a fault move suddenly, the stored up stress energy is released, causing an earthquake. So, internal horizontal and vertical movements due to tensional and compressional forces cause folding and faulting in the Earth's crust. This causes displacement in the crust. Such an imbalance causes earthquakes. For example, in 1906, the San Andreas Fault of California gave rise to a major earthquake that measured 8.3 on the Richter scale and broke the Earth's surface along a 402-kilometer length. Now we come to man-made causes of earthquakes. Human activity like construction of huge dams, nuclear explosions, blasting of rocks, mining, etc. near fault zones are responsible for earthquakes. Koyna earthquake in Maharashtra was caused by construction of the Koyna Dam in a seismically active region. Chemical wastes dumped into the ground and underground explosions in the USA caused several earthquakes in Colorado in the 1960s. This is the picture of the Koyna Dam in Maharashtra, which was responsible for the Koyna earthquake. Now we will discuss the anatomy of an earthquake. The tension caused by the movement of the Earth's plates builds up until it is released in the form of powerful vibrations. These vibrations travel in three types of waves. So first we have the P waves, the primary or push waves. P waves are the first earthquake waves to be recorded on the seismogram of an earthquake. They are compressional waves, that is, the particles vibrate in the direction of movement of the wave, similar to a sound wave. They can pass through solids, liquids, and gases. As P waves travel through rock, the waves move tiny rock particles back and forth, pushing them apart and then back together, in line with the direction the wave is traveling. So if you look at this diagram, this is the direction in which the wave is traveling. And as you can see, the P waves are pushing and pulling the rock. Here it is being pulled together, here, and here it is being pushed apart. Just like sound waves push and pull the air. Next we have the S waves, that is secondary or shear waves. S waves are recorded on a seismogram after the P waves. They are distortional waves in which the particles vibrate at right angles to the direction of movement of the wave. S waves travel through the Earth's interior but cannot be transmitted by liquids. As S waves move, they displace rock particles outward, pushing them perpendicular to the path of the waves. This results in the first period of rolling associated with earthquakes. So as you can see in this diagram, this is the direction in which the wave is traveling. And the S waves are displacing the rock particles outward, pushing them perpendicular to the path of the wave. Next we have L waves, that is surface or long waves. These waves travel along the surface of the earth and are recorded after the P and S waves. Two types of L waves are identified: love waves and Rayleigh waves. Surface waves are to blame for most of the damage caused by an earthquake. They move up and down the surface of the earth, rocking the foundations of man-made structures. Surface waves are the slowest moving of all waves, which means they arrive the last. So the most intense shaking usually comes at the end of an earthquake. So the L waves or surface waves make the surface of the earth move up and down, very similar to the waves moving on the surface of the ocean, and therefore they cause the maximum destruction. Now let us understand the two terms, seismic focus and epicenter. Seismic focus is the point of origin of seismic waves within the earth. So this is the seismic focus. The earthquake waves originate from the focus and radiate in all directions in concentric circles, as you can see in this diagram. Then we come to epicenter. Epicenter is the point on the Earth's surface directly above the seismic focus. The intensity of vibration is maximum near the epicenter. I conclude my lecture here. In today's lecture, I discussed the meaning of earthquake, the different causes of earthquakes, and the anatomy of an earthquake. Thank you and have a nice day.